Alright, so I guess this will be the third video in my series for college algebra. And I guess I'm going to start all these videos, at least these first few, the same way. The idea of a function, it pairs two things together. It pairs an x and a y. X and the y could be, just use your imagination. Think of all the kinds of things that it would make sense to pair together. Okay? Anyway, so that's what a function does. It pairs an x and a y together. And how you could do that is, I guess you could have an equation that does it. Have we seen examples like that? Yeah, here's an equation. Well, it'll pair x's and y's together. 1 for x gets paired with 34 for y. Sure. It'll do the job. But what if I just had a graph? Does that pair x's and y's together? Sure, same thing. And here I drew just completely generic graph, kind of like what you would see on the assignments. And the graphs on the assignments, you have like actual graph paper and so on. And in this one, I just, you just use your imagination. Like that point, that'd be like -2 for x and 5 for y. So that's like 2 spaces left and 5 spaces up if you had graph paper. Okay. In this point, 7, 4. All right. So 7 spaces to the right, 4 spaces up. So that's the whole context. I just didn't want to take the time to draw the whole graph with graph paper when it's just easy for me to explain to you like that. Now, x is left and right, and y is up and down, and this picture pairs x's and y's together. Okay, so you can pair them together with an equation. You can pair x's and y's together by just like literally writing them down paired together, or you can have a graph. It's all the same thing. All right. Now, if we want to be real obvious, we might say like, all right, that point being what it is says that x being 7 gets paired with y being 4. If you want to be really obvious about it, you can say that. Okay. All right. Now, here it says calculate what f of 4 is equal to. And have we seen anything like that so far? That seems kind of familiar to me. I know we have. Like in this function, yeah. So there's a function. If you put -3 into that function, you get -18 out. Okay. If x is -3, y is -18. That's another way to say it. So, all right. It's asking me if I were to put 4 in, or if the x were to be 4, then what would the y be, or what would the output be? What y gets paired with x being 4? And I think the answer is right down the picture. You just got to know how to interpret what you see. So I'd say, okay, well, like that point right there, it has x being 4 paired with y being -2. That's the y that gets paired with that particular value of x. So we might give our answer like this. We might say, as a matter of fact, for that function, f of 4 is equal to -2. Okay? All right, that's simple. This other one seems the same, but it's asking us in a little bit different way. Isn't it true, if you've been following the videos and the concept so far, a function just pairs y's with x's? All right, that's what it does. And I suppose reading this one, it says f of x is 5. It's like here the x is the mystery. The input is the mystery, and 5 is the output, or the y. All depends on how you want to look at it. So, I might say, okay, is there a point up there indicated where y is 5? And for that point, what's the x that gets paired with it? Well, I can look right there. It pairs x being -2 with y being 5. So, how would you answer it? I guess just if you use my math lab, you got to type the answer in a certain way. If you're taking a paper test, maybe you can just write the answer down. But let's give the answer like 2 ways. We might say, okay, in that statement, x has got to be negative 2. Or if we want to, we could say, all just depending on how we're supposed to give the answer. F of negative 2 is 5. If x is negative 2 in this function, then the y is supposed to be 5. Okay. All right. So we read the information off of a graph, but it's the same concept. A function pairs x's and y's together. All right. Okay. So another deal. The next thing that you get taken into with the assignments is the notion of a piecewise function. And you might look at this and say, well, now you're just taking it too far. What's the deal? Well, okay. We'll do this problem. I'm gonna fast forward a little bit to an example that you'll see in the homework, okay? Here's a scenario that, it's simplified a little bit from real life, but it's still realistic, and it will give you the basis to understand what we're trying to do. But say we got a telephone plan, and $40 includes 350 minutes, okay? And every additional minute after that 350 that you get for 40 bucks is, I put $0.25, so you could say 25 cents. 25 cents for each additional minute. If x is the number of minutes used, the function to calculate the cost, like your phone bill, would have to be it'd have to have two cases. Like, it's $40 if you use up to 350 minutes. If you use more than 350 minutes, then it's $40 plus 25 cents per additional minute. That's all that says. How is that the additional minutes? Say you talk on the phone 351 minutes. How many additional minutes is that? One additional minute. What's 351 minus 350? It's 1. So this, literally in terms of a mathematical formula, calculates how you might establish your phone use and your cost, okay? All right, so I'm saying that just to tell you that if this looks crazy, then it's not. It's realistic. Some functions have these different conditions in them, okay? And it's not that bad. All you really have to do is pay attention to the ifs. Just follow the instructions. It's like saying, you could look at this and say, all right, a function just pairs x's and y's together. This function says y is found that way if you plug in this kind of x and x is less than 0, and y is found that way if you plug in this kind of x. You just literally follow the instructions. Okay. All right. So let's do both these calculations. Maybe you've been catching on with the videos so far. You can pause it. Maybe you can do those and get the answer. But let's see. So what's this saying? It says that I'm going to let x, the input of the function, to be negative 2. Which one of these cases does negative 2 for x actually satisfy? Is negative 2 bigger than 0? No. Negative 2 less than 0? Yes. So that's the formula used to calculate your output or your answer or your y, however you want to look at it. So I'd say, all right, 5x plus 3. 5 times the input plus 3. So I'm going to do 5 times my input is negative 2 plus 3. All right. And I just do the math. What's 5 times negative 2 is negative 10. Negative 10 plus 3, negative 7. And I would just say, well, there's my answer. Okay? That's my y. That's my output. And this function, if negative 2 goes in, then negative 7 is what you get back out. If x is negative 2, y is negative 7. All right, we'll do one more. So what's f of 0? Well, again, I swear, all you got to do is follow the instructions. So what are we saying? We're saying I would like to let 0 be the x, 0 be the input. Which one of these does 0 satisfy? Is 0 less than 0? No, that just sounds goofy, and that's not right. Is 0 greater than or equal to 0? I guess yes. technically 0 is greater than or equal to 0. All right. So it's that one is going to fall under this. We calculate our answer that way. We get our output like so. So let's say 4 times the input plus 7. So 4 times 0 plus 7. What's 4 times 0? Nothing. So 0 plus 7 is 7. So we get 7 for our y for our output. Okay. All right. So let's do one more that's like this. So here's one that would at least appear a little more complicated. Let's see if it really is. The instructions still apply the same way. Just follow the instructions. Just do what the ifs say. Take the input, whatever it is, do what it says. All right. So now one thing I haven't talked about is we can give functions different names. Like f of x is a normal name that we give a function. But it doesn't have to be just like that. Let's see if I, here like capital F stood for Fahrenheit temperature, and the C right there stood for Celsius. So you can use whatever letters of the alphabet you want. This function's called h of x. But whatever, that doesn't really matter. That's not going to get in the way. So here, h of 3. 3 is the input. If 3 were the input, if 3 were the x, which one of these does that satisfy? Which condition? Is 3 not equal to 5, or is 3 equal to 5? I hope you don't think 3 is equal to 5. It's not. So that input satisfies this condition, and that's the function, the formula that we use to get the answer. So I put 3 in, I say into that 3 square minus 25, 3 minus 5. Okay, now I got to do the math. That's 9 minus 25. 3 squared is 9. I get negative 16 over 3 minus 5. That's negative 2. And then we know what 16 over 2 is. It's 8. Negative 16 over negative 2. Also 8. Okay. So 3 is the input. 8 is the output. 3 is the x. 8 is the y. Okay, now let's look at this other one. H of 5. Okay, so again, you got to decide which one of these ifs, which one of these conditions does 5 satisfy? Is 5 not equal to 5, or is 5 equal to 5? That number, like, remember, we're saying that this is the x, that satisfies this one. That x is equal to 5. That's the one it works for. It doesn't work for that one. Okay? So if we're going to make that our input, you plug it into that formula. Now you might think, is that a typo? It says 7. Should it say 7x or 7 plus x? No, it just says 7. It just says that 7's the answer. It just says literally, y is 7 if x is 5. If x is 5, y is 7. There's no math to do there. You just got to realize how to read it. Okay? All right. So there's our simple examples on piecewise functions. Let's do real quick. There's going to be some graphing on the assignments, so I need to address that. Let's see about how do you graph something real simple, and then we'll graph a piecewise function. All right. So anyway, if I'm going to draw a graph, I guess the simplest way to do it is to make a table, okay, where I'll choose the x's and I'll calculate the y's. And the thinking is if I choose enough points, there will be some kind of visual pattern that should be real obvious, okay? How many points do you need? Well, it depends on how complicated that graph is actually supposed to look. All right, so there's no hard rule on how many points to use, but let's say this. Let's say I'm going to choose I mean, here's a basic strategy. I might choose like a negative number, 0, a positive number. It can be somewhat random, but you can just kind of spread the points out. So those are the x's. What y's do you get? What do you get if you put negative 2 in there? What's negative 2 plus 2? 0. What if you put 0 in there? You get 2. 3, you get 5. Okay? And I'm just wondering, like, if I now were to plot those points on graph paper, if I would see a pattern to it. Okay, so here I'll take my time. I'll draw a fairly accurate graph. Put my marks real even. I want it to look pretty good, so. And x is left and right, y is up and down. Now, if I did my math right, there should be a pattern there. So, first point, negative 2 for x, 0 for y. That's here. Second point, 0 for x, 2 for y. So, no left, up 2. Here. And last point, 3 for x, 5 for y. So let's see, 3 to the right. 1, 2, 3, 4, 5 up. So I get like say right there. Now, do you see a pattern? I mean, does that look like a bunch of random dots? No order, no pattern, totally random, or does it look like something? I had tried to draw a nice, neat scale there. It looks like, here's the pattern I see. Straight line. Okay. All right. So what's your graph? Well, it happens to be a perfectly straight line. That's the pattern that I see. Okay. Now, if we go to graph one of these, we do it the same way, but we have to be careful with the instructions. Remember, it says y is x plus 5. You use that formula for these x's, and y is x minus 5 for those. Okay, so here's what I'll do. I mean, I guess once you learn this, you can, of course, when you get good and learn anything, you can do it faster, find your own shortcuts. But I'll do like this. I'll say, okay, y is x plus 5 if for x less than 4, so I'm going to have to fill out my chart like that. Because, you can't put any numbers that don't abide by that right there into that formula. I'll fill this out. I'll see if there's a pattern. And then I'll make another little table. And it says x greater than or equal to 4. And that gives me y is x minus 5. Okay? And how many points you need? 3 is probably okay. Let's do this one first. If you had to fill this chart out and you had to follow those instructions and let the x be greater than or equal to 4, what's the first number you think you choose? It says x can be 4 or bigger. X is greater than or equal to 4. 4 would be the first one I'd choose. It's the first one that's allowed. And then I'll do, how about this, since I know that both these are lines, I'll say 6, okay? Is 6 greater than 4? Yeah. Could I choose 7 and 8 and 9 and 10? Yeah, we don't have all night though, so 4 and 6 is good. So what's 4 give you if you put it in there? 4 minus 5 is negative 1. What's 6 give you in there? Gives you 1. All right. Okay. Would it keep going? Could you put 7 and 8? Yeah, x is greater than 4 goes forever. Okay, so let's put this much down. All right. I got my graph. I'm going to put my graph over here. All right. And x is left and right. Y is up and down. 1, 2, 3, 4, 5, 6, 7, 8, 9. That should be good. And if you have my math lab, then it'll have a little grid for you. It'll generate the graph paper for you. But so 4 is where this one begins for x. Y is negative 1. So I'm going to get like this point right here as my very first point. And then if I let x be 6, y is 1, so that's here. Okay, now you might be tempted, you might say, okay, it's a line. If I plotted another point, I'd get a point right out there. But it's just going to be like this. How come I don't draw the line past that point? You know, here, right here, here's 4 on the x-axis. Well, because, you know, this particular thing in the part of the graph that it contributes starts at 4 and it goes bigger. It goes from 4 over, according to the points I found on my table. So I know it doesn't go past that. All right. Okay, now this one, you know, this x greater than or equal to 4, well, that's all it is. Okay, with this other deal. All right, we got to choose numbers again. Here's the trouble, like it says x is less than 4. What's the first number you'd choose? I'd feel like people would say, well, 3 is less than 4. Okay, and 2 is less than 4. Do these numbers abide by that? Sure. Problem is, though, that, you know, there's what's the very first number we should choose? What's the very first number less than 4? Somebody might want to say 3.9 or 3.99 or 3.999, and that just gets way too crazy. So what we do is even though 4 is not allowed, we'll put it in anyway, so that we don't have to put some crazy number like 3.999 in. And we'll make the note that, you know, that point that we get is technically left off. Okay? All right, so what happens when you put 4 in? What's 4 plus 5? It's going to be 9. But that point will be, this really has to be left off. And we'll draw an open circle to indicate that. It's just so much easier than like going to like 3.9 and trying to put a point. Nah, we're not going to do that. What about 3? You get 8. And what about 2? You get 7. Okay, so let's put those down. 4 for x, 9 for y. 4 for x, 9 for y. That'll take me all the way up here, but you know, that point really is not included. When I draw an open circle, that's just my way of saying that the graph goes to that spot, but that point is not actually on the graph. 3 and 8. So 3 and 8 is here. That point's on there. 2 and 7. 2 and 7 is here. I see a pattern. It's another line. Okay? And it goes to the left forever. The arrow indicates that pattern you see just continues like that. Because any x less than 4 can be put in this equation. You're just going to get more points over here forever and ever. So that's what our graph would look like. Be 2 disconnected pieces. This point is open. It's technically not on there. And you might say, well, if it's not on there, why are you drawing it? Well, because if I erase it, it won't be clear like where this line actually is supposed to stop. So we just draw the big open circle. And when anybody sees that, they understand that, okay, I got this line. It goes right up to that spot and it stops. It does not actually include that open circle. Whereas this point is included. All the ones that I fill in are included. So our graph, okay, to draw that graph, looks like this. Anyway, so that'll take you through most of what, at least for our class this semester, is my math lab assignment number 2. Good luck with that. Email with questions. Request other videos if you want to. Have a good night.